Hello, and welcome to Compadre Learn. In this brief tutorial video, we'll cover the R exercises associated with the lesson Additional Exercises. Let's begin. In this video, we'll cover two learning objectives. First, we'll calculate population growth rate and damping ratio for Compadre and Comadre data. Then, we'll plot a subset of Compadre and Comadre data on a map. For this lesson, we'll be using R and RStudio, which can be downloaded at the links on your screen. If you're unfamiliar with this software, please visit the links on your screen and familiarize yourself before continuing. We'll also be using the R packages Rcompadre, PopBio, Maps, and Diagrammer, and you'll be prompted to load these during the lesson. You can download the R code used in this video as an R file or PDF directly from the web page. You can also follow along with the lesson on the web page itself. Objective 1. Calculate population growth rate and damping ratio for Compadre and Comadre data. Let's start by loading the required packages. For this video, we'll be using the R file provided on the tutorial webpage. Now, we can use the cdb fetch function in the Rcompadre package to download the latest version of the Comadre database. You can also download the latest version of the Comadre database from the website by using the link provided in the lesson. If you downloaded the Comadre database from the website, you will need to convert this to an S4 Compadre DB object for use with the Rcompadre package. You do this by using the function as_cdb. If you use the Rcompadre package to download the database, you can skip this step. For Objective 1 of this exercise, we'll create a subset of the Comadre database that we'll call X. This subset will consist of data on ray-finned fishes, containing mean matrices that have a duration of longer than 3 years and a matrix dimension of at least 3 by 3. Now that we've subset our data, we can begin to analyze these data by applying functions in a loop or by using lapply. For example, to calculate growth rate and damping ratio for this subset of matrices, we'll first create an empty data frame to accommodate the output using PopBio. Now that we've created this output, we can examine it by typing the word output in the console window in the bottom left. Since this output is populated in the same order as the metadata, we can also add the species name to this data frame. We can also use histograms to plot the population growth rates and the damping ratios derived from these matrices. In the histogram we created, the vertical dashed red line indicates a population growth rate equal to 1. Objective 2. Plot a subset of Compadre and Comadre data on a map. For Objective 2, we'll produce a world map with population growth rates of a subset of studied populations given some selection criteria and color codes to indicate the value of lambda. We'll split these between lambda greater than 1, lambda equal to 1, and lambda less than 1. We'll subset mean matrices for all species in carnivora in wild populations in the northern hemisphere with no issues for survival, for which the matrices have split into A equals U, F, and C, and for which reproduction was explicitly modeled. Our subset X is now a version of the Comadre database that contains only the matrices that match our search criteria. To calculate population growth rate for this subset, we'll first need to create an empty variable to accommodate the output from lambda calculations. Next, we'll create a for loop to examine each of the matrices in turn. This function will calculate lambda for each of the matrices and then populate it in the empty variable we created above. Finally, we'll create a vector of color hex codes that can be applied according to the estimate of lambda. This is done using the color rant palette function to go from green for high values of lambda to red for low values of lambda. Here, paste is used to append a value of 90 to the hex codes to allow transparency for aesthetic reasons. Now that the setup is complete, we're ready to generate our map using the Maps package. In the map we created, the points are color-coded based on their value of lambda, with bright green indicating a high lambda and bright red indicating a low lambda. In this case, points are jittered slightly to improve visibility of nearby populations. This concludes our tutorial video. To find more helpful tutorials like this one, please visit compadre-db.org/learn.